Lesson 15.11 is secant line limits numerically. It says the function f of x equals x squared minus 10x plus 18 is graphed below. Determine the slope of the secant line of f for each of the intervals indicated in the table. Find the average rate of change of f on the interval 7, 7 plus h for each value of h shown in the table. Write your answers as decimals. So let me kind of simplify what this is saying. We have got a quadratic function graphed here in this solid black line. They want us to find the slope of the secant line, which means it touches at 2 points. So we're really just doing change in y over change in x, but we're going to keep changing the interval. But we know that the first x value is always 7. And you can see here that when x is 7, y is down here, kind of like, what, -3-ish? We don't know until we plug it in. So what I want you to do is think about the brackets here. These are x values. We want to go from x is 7 to 7 plus h. And we're going to do it multiple times. Let's use the equation to figure out when x is 7, what is y. So I'm going to do f of 7 equals 7 squared minus 10 times 7 plus 18. That's 49 minus 70 plus 18. And that's -3. Okay, so now if I want to find the first interval here, my h value is 1. So you're going to plug in 1 here. So I'm going from 7, -3, I'll put interval number 1 here, to 7 plus 1, which is 8, comma, what? So now I got to plug in 8 for the y. And it'd be 8 squared minus 10 times 8 plus 18. And again, that's just coming from the problem that tells me, here's my equation, I can plug in an x, get out a y. So let's just start doing this all on the calculator. I'm going to put parentheses x squared minus 10 times 8 plus 18. Oh, I didn't even do 18, I did 10. Change that real quick. Okay, it should be 2. Now that I have 2 points, I can go ahead and find slope. So I'm going to do y2 minus y1. So 2 minus -3 is plus 3. 8 minus 7. That's 5 over 1, which is 5. That's what they want you to put here for average rate of change. The slope is 5. All right, now let's do the second interval. We still know we're going from 7, -3, that point. But now my second point is going to be 7 plus 0.1. Well, 7 plus 0.1 would be 7.1 to something. So now I want to use my formula, which I'm just going to use this again. I'm going to go up here and select it. And everywhere that I had 8, I'm going to change that into 7. And I think I'm going to have to go second insert here. 0.1. And then arrow over here, 7, and then insert 0.1 plus 18. So that'll tell me that when x is 7.1, my y value is -2.59. So then they want me to find the slope of this. So it's going to go 2.59 plus, sorry, -2.59 plus 3 over 7.1 minus 7. That would be 0.41. And I already know that 7 1/10 minus 7 is 1/10 or 0.1. And when I divide that, it's just going to move the decimal 1 place to the right. So it's 4.1 is my slope. Okay, and then what I want to show you is what's happening is first my distance was 1. So I went from 7, the point at 7, to the point at 8. That slope would be here to here. It's an average rate of change. It's not super accurate. But then I go to 1/10 away. So then I would have 7 and 7.1. Now that slope would get a little more accurate. It's hard to see here on Delta Math, it changes colors, but the closer you get to x is 7, which will get closer and closer because here's the, that's nearest 10th, 100th, 1000th. Closer you get, the more accurate your slope is. Picture zooming in and you're getting closer and closer to that specific rate of change. They call it an instantaneous rate of change because it's how it changes at that instant. But anyways, now let's do our third interval. We know we're going from our first 0.7, -3. Now my h value is 0.01. So 7 plus 0.01 is 7.01. Plug that in. So again, I'm going to go back up to my calculator and I'm going to steal this formula. And I know that I have to put 0, 1. Okay. That gives me a y value, and you don't want to round, -2.9599. Then I want to do slope formula of these 2 points. So it's going to be -2.9599 minus -3, so plus 3 over 7.01 minus 7. Okay, so that plus 3 gives me 0.0401. That subtracts, I know, to give me 0.01. So divide. And now I get 4.01. See how it's getting closer. First it was a slope of 5. Now we're getting 4.1. Now we're getting 4.01. And then the last interval, I'm going to go from my 0.7, -3 to the new point, which is 7 plus that h value. So it's 7.001, comma something. Oh, I cleared out my formula. So I'm going to do 7.001 squared minus 10 times 7.001 plus 18. And again, do not round. -2.995999. Slope is going to go that number plus 3 over 7.001 minus 7. So we should be getting good at this because it's the same thing over and over. That plus 3 gives me 0.004001. That subtracts to be 0.001, which gives me 4.001. So that goes in here. So again, what you're noticing is that as this h value, this distance from 7, gets closer and closer and closer, this slope is getting more precise. So we could say here that it's about a slope of 4. And that's what secant line limits are all about.